Okay, let's have a look at this molecule and see if we can come up with a name for it. So we can notice here that there are 6 carbons in the longest chain. We can see coming off the top there are 3 different atoms, substituents, a chlorine, a bromine, and a fluorine. That's a chloro, a bromo, and a fluoro functional group. And we can number them 2, 3, 4 to give the smallest possible number. Now we can go about naming them. We put the substituents, we're going to put them at the front as prefixes, and we're going to put a number in front of each one. But what we're going to make sure we do with this one is we put them in alphabetical order. So the name for this is 3-bromo, 2-chloro, 4-fluorohexane. Okay, so if we look at this molecule, we can see that there is a double bond coming off, near the right-hand side of the molecule, and that we have 2 identical functional groups, 2 bromine atoms coming off the carbon of the double bond. Now, because there is a double bond, and off the second carbon, there are 2 groups or atoms, the bromine and the CH3. And off the third carbon, there are 2 groups or atoms, the bromine and the CH2, CH3. This can exist as cis and trans isomers. So in this case, when we name this, we are going to make sure we put cis or trans in front, in this case cis. We are going to, when we talk about the bromos, put the number of where they're at and the number of where the double bond is at. So the name of this molecule is cis 2,3-dibromopent-2-ene. Okay, if we have a look at this molecule, see if we can name it here. We can see that there are 2 functional groups here. There is a bromine coming off the carbon on the left, and there is a double bond on the right. Now, remembering that the bromine is a bromo group, and it will be written as a prefix at the start of the name, and the double bond is an ene or alkene group, and it will be written as a suffix at the end of the name. So if we number it, we also need to be aware that the alkene has a preference, or it's going to have a lower number compared to the bromine. So the name of this is going to be 4-bromo, because we number from the alkene side, so it's number 4 the bromo comes off, 4-bromo-but-1-ene. Okay, so let's have a look at this molecule. There's quite a lot of carbons here. We can see the longest chain with the fluoro functional group, the fluorine on it, the fluoro functional group, has 5 carbons in it, so this is going to be a pentane. We can see coming off the middle, the 3rd carbon is an ethyl group, and coming off the 1st carbon is a fluoro. Now, we might attempt at the start to write this name as 1-fluoro-3-ethyl pentane, so the numbers are in numerical order, but actually we write the prefixes in alphabetical order. So the correct name for this would be 3-ethyl 1-fluoro-pentane. Okay, so here we have a rather straightforward molecule, it seems like, for a start, as long as we remember that the fluorine atoms are the fluoro functional group, and it's put as a prefix at the start. We don't need to give a number to them because there is only 1 carbon that they can come off. And when we have 3 of the same substituents coming off in a molecule, we use the prefix tri in front of the fluoro. So this molecule is going to be called trifluoromethane. Okay, if we look at this molecule here, we can see that there are 2 fluorine atoms coming off the molecule, coming off the 1st and the 3rd. Remember, we number from the right because that gives us the smallest possible numbers, 1 and 3. If we'd numbered from the left, then the numbers would be 2 and 4. So therefore, we go with the smallest number from the right. They are fluorines, fluoro groups. The longest chain is 4 carbons long. So this molecule is going to have the name 1,3-difluorobutane. Right, on first inspection, this molecule looks kind of busy. We can see that there are 5 carbons in the longest chain, so it's going to be a pentane molecule. We can see also that there are 3 substituents coming off: a fluorine atom, a chlorine atom, and a methyl group. So we have fluoro, chloro, and methyl as our substituents. We know we're going to write chloro and fluoro at the start, and we're going to put them in alphabetical order. We can see the chloro comes off the second carbon, the fluoro off the first, and the methyl off the third. So we are going to name this 2-chloro, 1-fluoro, 3-methyl pentane, and we ensure that it's all in alphabetical order. Right. Okay, so let's have a look at this molecule here. This is a simple molecule in that has 2 carbons, so it's an ethane group. We can see 2 fluorine atoms coming off each carbon. So it's going to have the fluoro prefix. We need to number the carbons, 1 and 2, and we're going to have to give the place number of each of the fluorines and call it 1,2-difluoroethane. And the reason why we need to have the numbers in such a small molecule is there is another version of difluoroethane, and that would be if they both came off the first carbon, and that would be called 1,1-difluoroethane. Okay, if we look at this molecule here, we can see that there is an emphasis on the double bond in the middle. There are 2 chlorine atoms coming off on the left at the top and the right at the bottom. These are the chlorofunctional groups. We can see because the carbons have a double bond, and off each carbon there are 2 different substituents or 2 different groups or atoms, a chlorine and a hydrogen off the first carbon and a chlorine and a hydrogen off the second. Then this can exist as geometric isomers, and this does exist as the trans geometric isomer. So this molecule is going to be called trans 1,2-dichloroethane. Okay, if we look at this molecule and we take care, we can see that there are only 2 carbons in the main chain. So this is going to be called ethane. We can see that there's 2 fluorine groups that are called fluoro groups. They are coming off the first carbon. We have to give the position or address of these fluorines, because if we didn't, someone might be confused and not think they both come off the first one, but could think one come off the first and one come off the second. So this molecule is going to be called 1,1-difluoroethane.